Good morning, mathematician. Welcome to week 22. This is our Monday column. We are starting off with some partial products down below and an area model for division on top. Notice in this model, we actually already have our dividend broken up because our dividend is 755. Here I see 500, 250, and 5 together. That gives me the 755 of my dividend. So I'm going to put my divisor outside the box, what I do in my area model, and I'm going to think about how many groups of 5 did I get to use up 500 of my dividend? Well, I used 100 because 100 times 5 is 500. Here I ask myself, how many groups of 5 did I use to get 250? Well, that was 50 groups of 5 because 5 times 5 is 25, and then I had my 1 0 to carry. How many groups of 5 are in 5? Well, that is 1. This shows that distribution of my dividend, and of course, I'm seeing my quotient on top. Let's translate that, how that looks in a partial product model. Well, the first thing I did was I used 500 divided by 5, and I found that to be 100. That equates for this very first column. In my second column, I did 250 divided by 5, and that gave me for that section a quotient of 50. Now I had 500 divided, or excuse me, 5 divided by 5, and that gave me 1. Together, when I add my 151, I have 151. That is my very first problem in this Monday column. Let's go ahead to our next one. In our next problem, we are looking at, instead of having the dividend already divided, we are going to completely finish this problem. So once again, I'm going to take my divisor and I'm going to put it right beside the 6 is my divisor. I'm going to start by saying, okay, what's a reasonable first take from my dividend, 852? Well, I know I could use 600 groups of 6, and that would use up 600 of that 852. Hmm, what would be a reasonable next take? Once again, boys and girls, we can think. We started with 852. We've now used 600 when we did those 100 groups of 6. So I can look and see that I have 252 left. Well, I know that 6 times 4 is 24. And notice I'm very far away from that number. But if I use my 0, if I'm now taking, instead of just 4 groups of 6, 40 groups of 6, 6 times 4 is 24. Add a 0 to make that 40. Add a 0 to make this 240. Now I've taken a good chunk of that dividend and I only have 12 left. Well, how many groups of 6 can I get from 12? That 12 remaining in my dividend, I can get exactly 2 groups. When I do that, boys and girls, take note, I have now used all that dividend, and the last thing I need to do is show it as a partial product. The first thing that I did was 600 divided by 6, and that was 100. Then I had 240 divided by 6, and that was exactly 40. Then I had 12 divided by 6, and that used up 2. Let's join those together. 100 plus 40 plus 2 is 142. That is my second problem in this Monday column. Now let's move down to partial quotients. When I'm thinking here about partial quotients, remember, boys and girls, we're going to take this same number, this 852, my divisor of 6, my divisor of 6. So I'm thinking about those groups that I swiped away from my 852. We should get to the same answer, but we're going to show it with a different strategy. I'm going to come to the side and just give myself a little bit more room to work so that you can see it clearly in my camera. So here, boys and girls, what we're going to do is we are going to ask ourselves, how many groups of six can we start with taking away from 852? Just like before, and what we've grown accustomed to, if you're unsure, think about, can I take a group of 100? Can I take a group of 10? Can I take a group of 30? Play with those numbers until you find something like that, like Goldilocks is a just right number. Here, 100 groups of six is a good first take because notice that's using up a good portion of that dividend. Now I have 252 left in my dividend. I'm going to ask myself, well, 6 times what gets me something close to 25? And then I know I can add a 0. So I'm going to go with 40 because 6 times 4 is 24. And then I have that 1 0 that I can tack to the end. And sure enough, I see what a good take that was because I only have a difference of 12. Well, 6 goes into 12 exactly 2 times. So that uses up all the rest of my dividend. There's no remainder. The last thing that I need to do is combine those values, and I find my answer is 142. Of course, that matches what I found in the last problem, which it should. It's the same problem, but with a different strategy. Boys and girls, remember, all of us are going to have our go-to strategy, the strategy that we do most often. We want that to be the one we're most efficient with and most accurate with, but it is good for our brains to see and analyze different ways to solve. Now we're going to come down and we're going to switch it up. Here, instead of thinking about dividing, now we're thinking about decimals. It says label the numbers on the number line below. We're going to compare 0.227, which of course I read as 0 and 227 thousandths, and 0 and 223 thousandths. And we're going to compare those, of course, with comparison symbols. Well, notice, boys and girls, on the number line that's provided, I see 0 and 22 hundredths and 0 and 23 hundredths. I have all of these intervals in the middle, and if I count them out, I can see that I have exactly 10 intervals. That should make me think, well, I can actually turn this into thousandths. Because if this were already thousandths, I would have 220 thousandths because I could add a 0 to this, right? And I would not change the value. I'm going to switch to a pen that's a little bit smaller for the sake of this. Now I'm going to label this as decimal 221 because if this is decimal 220 or 220 thousandths, this can be 221 thousandths. This can be 222 thousandths. This can be 223 thousandths. Notice, boys and girls, I'm kind of going up and down just to give you, hopefully, enough space to write these and see these. Let me outline this too, since that is very small. This is 224 thousandths. Now I have 225 thousandths. Now I have 226 thousandths. Now I have 227 thousandths. Now I have 228 thousandths and 229 thousandths. And sure enough, here I have 230,000. If I were to turn that into a thousand problem, let me refocus that for you. Hopefully, let's see if my camera will help us out here. Give me just a second, boys and girls. I'm trying to help us see those teeny tiny numbers. And sure enough, they are teeny tiny numbers because we're thinking about thousands in order to claim all of those intervals. So now what we're going to do is we are going to label where we see 227 on our number line. Well, 200, 0, and 227 thousandths is right there. I have labeled that just like I was asked. Now we're going to label 223 thousandths, which is going to go here. 223 thousandths. Boys and girls, the very first thing I was asked to do was label all the intervals. I did that down below in blue, but man, oh man, I had to write small. Here, we're going to label 227 thousandths and 223 thousandths, just like I have above in this pink color. The last thing that I'm asked to do is write a comparison sentence. I am going to express that obviously this number is smaller than this number. I'm going to come to the side just so you can see it hopefully a little bit more clearly, because sure enough, we have put a lot of thought and a lot of writing into this teeny tiny problem. Notice, boys and girls, what I've written. 0 and 223 thousandths is smaller than 0 and 227 thousandths. Boys and girls, could it also be true if I wrote it this way? Absolutely. Here I have flip-flopped my numbers, so I flip-flopped my symbol as well. I know that 2 and 27 thousandths is greater than 2 and, or 0 and 223 thousandths. Okay? Our very last problem that we have today, boys and girls, is to think about an area model. And yes, indeed, we have a big problem to do, but that is not too much for us, mathematicians. We are going to think about this problem. There are multiple ways that we can draw an area model. I have decided today I'm going to keep my 9,024 all together instead of creating 4 separate columns. And instead, I'm going to break up this. So I'm going to have 100. I'm going to have 30. I'm going to have 9. And notice, I'm going to do it this way. Part of the reason I chose to do it this way is because I like this fact on top. Anything times 1 equals the number itself. So I can simply take these digits 9, 0, 2, 4, and I can add 2 zeros. And look how I've done a good portion of that multiplication problem already. I did 100 groups of 9,024, and I got that to be 902,400. Okay, now these next 2 lines, I do have to do a little bit of multiplication, where that way I can see what those partial products are. I'm going to use just a little post-it note over here and do some work on this, and then I'll transfer it into that part of the area model. Boys and girls, I am really looking at 9,024, and I'm going to do that times 30. But I'm going to start with multiplying it just times 3, and I'm going to remember that really I can just bring those zeros in, because really I can do the times 3 fact, and then I can make it 10 times greater by adding a 0, 10 times greater by adding a 0. Let's step through this problem. 3 times 4 is 12. Here's my 2. Carry my 1. 3 times 2 is 6 plus 1 is 7. 3 times 0 is 0. 3 times 9 is 27. That is my problem. And notice I made this factor 3 times bigger with a 0, so I made my answer 10 times bigger with a 0 as well. The answer to this problem, I'm going to keep it nice and aligned. The answer to this problem is 270,720. I've shown it on my paper. I have added it nice and aligned into my area model. Now, boys and girls, I'm going to do this times 9. So again, I'm going to write 9,024 times 9, just like this. Let me slide this up so you can solve along with me. 9 times 4 is 36. Here's my 6, carry my 3. 9 times 2 is 18, plus 3 is 21. Here's my 1, carry my 2. 9 times 0 is 0, plus 2 is 2, and 9 times 9 is 81. This is my answer to that problem. I have 81,216. Okay, boys and girls, if you've made it very aligned in your area model, then you, like me, can add your columns. If they are not straight and aligned, you need to rewrite them, because you don't want to make little errors because your work is sloppy or messy, right? Make sure we're keeping it nice and aligned. 0 plus 0 plus 6 is 6. 0 plus 2 plus 1 is 3. 4 plus 7 plus 2 is 13. Here's my 3. carry a 1. 1 plus 2 plus 1 is 4. Here I have 6 plus 7. I know that's 15. Here's a 5. Carry a 1. This makes a group of 10, doesn't it? 1 plus 9 is 10, plus 2 more is 12. So I have the digits of my answer are 1, 2, 5, 4, 3, 3, 6. Let's add our commas for easy reading. 1, 2, 3, comma, 1, 2, 3, comma. My answer is 1,254,336. Great job, mathematicians. That is our Tuesday, or rather Monday